So welcome to those on Zoom as well as those in the hall, and especially new members are here for the first time. We don't want to scare you off too much. It's not always as chaotic as this. It's usually worse, I think. Okay. So tonight's meeting is our members' images meeting, and it's where all our members send in images of objects that they've captured over the past few months, and sometimes at an earlier stage. So I'm just going to go through this part of it as quickly as I can. So a little agenda, we've got some notices, then Len is going to give us a news item, and that'll be followed by the presentation of the members' images. And finally, Richard will do a planetarium visit for us on Stellarium and tell us what's upcoming in the night sky. So just a little bit of notices for those in the hall: fire exits, left and right, and also at the rear. Toilets are also at the rear and on the left-hand side over there as you come in. We are recording this tonight so that those that aren't able to attend on Zoom, or those that are not able to make it here, that they have the opportunity of at least finding out a little bit about our images. So for the new members, and apologies again to the long-standing members that see this nearly every time, a little bit about our society, founded in 1968, so it's over 50 years old. It's currently standing at about 164 members, and we do have monthly meetings, usually here in this hall, on the last Friday of the month, but on occasions like this, where the festivals and feasts interfere with it and the school facilities need to use the rooms for something else, then we hold it at a different time. And we have our own observatory in London, and we have access to the planetarium here at the RMS. Richard and I are still due a visit to check to see that it's in working order, but we hope that we might be able to resume those planetarium visits as well. We do have an occasional newsletter or email that goes out with informative events. And just to mention about subscriptions, it's £16 for an individual, and a family is £24. Our website, SWHAS.org, it's in a state of limbo at the moment. We're doing some changes, but we haven't been able to implement them just yet. There's an observatory on the site as well, here on the right-hand side of the map. It's got a roll-off roof, and beside it is the planetarium. And route that we would normally take is this blue route from where we are located down to the planetarium. And when that happens, we'll guide you down as well, so don't worry about that. Sometimes we have meetings here in the Newmark Hall, which is this one here. It's currently used as a reception, so they're not too keen on us using that as a venue for our stuff. Because the gate is still not fixed, you'll notice it's open. We're not allowed to go back out that way. We have to exit by an alternative route, which is this blue route. So it's down by the planetarium, but then you skirt around the planetarium and keep left, then follow it round, and eventually takes you down a long avenue down to here onto the roundabout. The station is down here. So don't lose your bearings and turn the wrong way when you come out here. This takes you back up on the road to the M25 again. So if you come out and want to go to M25, you go this way. Okay. Just a little bit about our observing site. It's London, and this is a Google image aerial view. And on the site, we have the observatory. We have a hut, and basically you need the hut in all sorts of weather because it's pretty cold up there. You do get fairly clear skies, it must be said, so it's a useful observing site, and it's protected pretty much from the M25 by the hills around it, so we don't get as much glare there as you would near the towns and cities. There's a picture of our dome, and if you wanted to find it, the easiest way to do is search for SWHAS Observatory on Google Maps, and it'll bring you to that location. Then you can use that to take directions from wherever you are located yourself. So the next meeting is on January the 27th, and there's going to be Martin Lewis that's giving the talk. Martin is Astrophotographer of the Year winner again this year, and you know him very well because he's a member of WHAS, a committee member of WHAS, and he's been here several times. But every time he comes, you always learn something from him. He's a really very good educator as well. So he's won Astrophotography of the Year award again. I say that because he won it in 2018, and it's very unusual for somebody to win it, the main category, a couple of times. But he has actually won in all sorts of categories since 2018. Every year he's won something. But this year he's won a our moon category, and this one is called the shadow profile of Plato's East Rim, and very detailed picture indeed, you'll agree. And he got commended for this one of the ISS, picture taken from St. Albans, and he managed to capture ISS passing overhead. And again, I've got him commended in the people in space category. He also got picture of the week on the BAA for the Mars occultation. Quite a few people have done this. Martin also is a very well known for his planetary work, and he's done that. So if we could have Len up, please, to do the news item. Thank you.
Okay. If you're watching from home, you're very lucky because it's freezing in here, I tell you. Okay, well, this talk is a little bit of news about black holes. They come in all sorts of sizes, big and small. This one is enormous. It's 6.5 billion solar masses. And this amazing picture was taken by the Event Horizon Telescope. That's a number of radio telescopes around the Earth all linked up. But at the other end of the spectrum, they come quite small, down to about 5 solar masses. And one way of detecting them is with gravitational wave detector. And this chart shows you a number of black holes represented as little pairs of blue holes, pairs in blue, which have come together, combined into one larger black hole. So all these triples show you those events that have been recorded as when they come together, they distort space-time, and that is you get this result. Yes, now just below those, you can see some shown in purple. Now, they're noted as EM black holes. What that means is they're directly observed electromagnetic spectrum black holes. And that occurs when a black hole has a companion star, and it bleeds off matter from the companion star, which goes into the black holes and creates electromagnetic radiation, in particular X-rays. So that's another way of detecting a black hole. But again, this particular news is based on data obtained from the Gaia Space Observatory. Basically, it's mapping the sky in incredible detail, and it's just over halfway into its mission. It measures the precise position of stars, amongst many other things. And each time the camera passes the same region of sky again, it can see whether that star has moved or not. So it maps their absolute position, which is amazing, really. So this has provided a new way to detect black holes. And this is an artist's impression. And so this is the news. Researchers at the Smithsonian Center for Astrophysics in Cambridge have analyzed the Gaia data and found a regular star, just like our sun, moving backwards and forwards, clearly rotating around another body. They've looked closely at the position of that other body and found absolutely nothing. So the only candidate for that body is a black hole, and its size is estimated to be 10 solar masses. It's only 1,600 light years away. That pretty much makes it the closest black hole. When you consider the galaxy is 100,000 light years across, it's really a local object. This is an artist's impression. Of course, it's not a very good artist's impression. It's the only picture I could find related to the news, because it's showing the black hole, which of course you can't see. So how do you show a black hole that you can't see? Well, this is the best you get. And I think shows a few stars or something in front of it. So forget that artist's impression, but it's the best I could get. So the star orbits the black hole every 186 days. So it's far enough away that it doesn't lose matter to the black hole, and therefore the black hole itself is invisible. It's a little bit of a mystery. because the original massive star must have become a powerful supernova, which would normally have destroyed a star in that position. But we always like to have some kind of mystery with these things. So it's thought that there could be many more of these passive black holes in our galaxy. So the hunt is now on to find them. And that's the news.
Thank you very much for that, Len. Right, so we're moving on now to the members' images. And before I do that, there's just a few images that we took of the partial solar eclipse. We had a session in Castleberry Park. I think I may have shown you this before, but just to let you see what's going on. A few of us went down there with some telescopes. We had one that was just a basic white light filter, a better filter. And on this one, you can see some sunspots. You may not be able to see them entirely clear, but they're just about visible there. And the moon encroaching on the solar surface. Then a little bit later on, we have those, and still we have some sunspots there. One of the things that I found intriguing is that you can actually see the outline of the craters of the moon on the image of against the sun. That really surprised. Now, these pictures were taken just with a phone. They were not proper imaging cameras, so they're not particularly good, but they show, what can be done. And that was through a hydrogen alpha. And again, there was a fair amount of detail, even though it's a phone thing. So just looking at that enlarged area, you've got some really good prominences and flares. I'm told this flare was around 50,000 miles in height. So which is quite a lot, really. And you could easily fit the Earth through that if you were able to take it up there and pass it through. So tonight we've got a selection of images. First one, it will be James Hollingshead. I'll go through these just, and then Stephen King, Jared Sheldon, Pat Bork was unfortunately not able to make it. And I believe Antonio is joining us from Italy on Zoom. He'll talk about his images. Martin Weston isn't able to make it, but has sent some images, and ending off with Stephen Helsinger. So James, if you're able to come up to the stage, we'll try and talk you through yours.
Thank you very much. I'm James Hollingshead. I'm a relatively new member. I've not been earlier this year. I live in Watford, so light pollution is dreadful. You can't see very much at all when you look up. Sorry. So anyway, I
hear you. Sorry.
Said slow down.
Right.
So my first couple of pictures, I've only got 4 of them to show. My first couple of pictures are ones I took in my garden just with a standard DSLR camera and a lens on a tripod that wasn't moving. And this one, hopefully you recognise, is the Orion Nebula. That's about 40 minutes worth of exposure, but done in 1 second exposures because the camera wasn't moving. And so the stars were gradually drifting across the background. And so I had a little shutter release thing that I clicked down, and every 10 minutes or so I nipped back out into the garden and repointed it back to Orion as it drifted across the field, and then stacked them all together and processed it. So I got a nice picture of Orion, and very similar technique. I got up to about 3,000 images on that one. All of 1 second, so that one was nearly an hour, and I got a picture of Andromeda as well. And then in the exposures, so I went a little bit down that rabbit hole of getting a mount that tracked and moved around and followed the stars, and got a couple of filters, and I got that's a picture of the Cygnus wall in Cygnus, sometimes known as the North American Nebula, because if you look at it on its side, it's supposed to look a bit like the coastline of North America. And that was using a narrowband filter, which helps to deal with the dreadful light pollution I've got in the centre of Watford, well, not on the edge of Watford at least, but shooting out over it, and pick up a lot more detail. And that was suddenly up to about 4 hours of exposure. It's in much longer exposures, so I wasn't needing to take quite so many, and my computer didn't hate me quite so much for having to stack for days at a time while I went off and left it. And then the last one I took was this one, which is again on a very wide field, so it's only a 200mm lens, but of the some fairly famous targets up in Orion. So you can see the Horsehead Nebula in there in the flame, And again, that was about 4 or 5 hours with some broadband filters and a tracking mount. What's it?
That's excellent. Thanks very much for that. Very well done. Yeah. That's excellent. And just shows you what you can do with just a DSLR, among other things. So next up, we've got Jared Sheldon, please. If Jared can come.
I've only just got one photo. I've had some problems with my mount, and the motor went, and I had to get reinstalled. But this is one picture I took with of the Veil Nebula. Hasn't been processed. It's just one photo, and you can sort of see the witch's broom there. I hope to have more photos in 6 months' time when we have another members' evening, when my telescope will be sort of fully functional, and I'll be able to take lots of pictures.
So what camera were you using?
Oh, I was using a Astro camera, ASI 294, and that's an 8-minute exposure.
Okay, very
That's
good.
good. Thank you very much.
Okay, thank you. So next up, we've got Stephen King. Stephen, would mind coming up to the stage, please?
I actually bought the camera along. I took it with. Here it is. It's a pinhole camera. So this is basically a tin can with a pinhole in it. Inside there's some film, so to speak. I haven't actually worked out the SWHAS. So this is a 6-month exposure, and you can do longer. So obviously what we're tracking here is the sun. It's on all the time. So this is in this exposure. And these are the tracks. So information here, I think is probably evident. This is actually run from the summer solstice to the winter solstice. So it's the 6 months. So it's from June through to the as you can see, I missed the sun. And the sun on longest day going through here. And as you can see, I have a tree. That's about it. Other information in this is obviously there's a record gives months of daytime weather or the cloud cover, which explains why we get these dotted lines and indeed some gaps entirely as cloud cover. I actually find it quite interesting because as astronomers, we feel there's too much cloud around. And I think this one actually graphically demonstrates that it's quite a lot of obscurity. So I think you can make one of these yourself. I bought this. It's called Solar Can. Solar Can. It's a tin can, right? And you can buy them at a major market. I think the guy's done a great job. And you've got to find somewhere where it's got to fall off a bit obscure and things, just wire it up. Reveal the pinhole and try and remember where you left it to come back in the next month's time. I did a few, and several have fallen off where I put them. So there are trials and tribulations associated with it. I just opened this one out, so I quite like this image. Oh, this is about it. It's quite a sensitive paper inside the can. So once you get the photo paper, you should do that. So that instantaneously.
Hello, everyone. Antonio here. I'm relatively new to astrophotography and astronomy in general and to the membership of the association. So I've gone a bit overboard with like 10 pictures, 13 pictures. I'll go through a few. So this is my main gear. For those that like the technicalities, is Altair 80mm f6 apo refractor. Attached to it is the ESI 533 camera color, so it's a one-shot color. And then I love the little mount, which is the Skywatcher ZGTI, which is extremely light and portable. All of this gear can fit at a push in a backpack that travels with me. I've taken it to Greece, to Wales, to the darkest I can get, basically, because I take pictures as well from my home in central London, which is a Bortle 9. There's a couple of pictures in this collection that you see, but it's so much easier when you're in dark Wales, for sure. So maybe if you want to switch to the next picture. Thank you. So first picture is Bode's Galaxy. I took this one in Wales, which is a Bortle 2-3 in Ceredigion, central Wales. This was done actually with a Altair GP Cam 3, which is what they call a planetary camera. Is uncooled, but this was March, was cold enough outside. Totally unguided, no dithering, no, some black frames for calibration and no flats. As you know, this is M81, is a galaxy in Ursa Major. It's about 11-12 million light years away from us. And you can see probably, I don't know, in your screen, but you should be able to see quite a lot of star formations areas around its the outer edges of that, the purple, star formation areas. Next one, please. Penguin Galaxy M101, again from Wales in March 2022. This is 3.5 hours of integration. So probably pictures of my pictures were at the time unguided, so half a minute for 3.5 hours in total. M101 is a large galaxy. It's about 70% larger than the Milky Way. It's about 1 trillion stars. But again, in here you can see some star formation areas that pop out quite easily from that galaxy. Next one, please. So this is Triangulum Galaxy. I took this one from my hometown in the Italian Alps, although it's actually in the valley, so it's a Bortle 4 and 5. I took this one with the cooled camera, no filters. It's only 1 hour and 23 total exposures. But I think on this one, I used the filter for a short period to enhance the star formation purple areas. Filters allow you only to see hydrogen alpha areas better. And M233 is one of the third largest in our local group of galaxies, behind the Andromeda Galaxy and our Milky Way. Apparently, I have not seen it, but it's possible to see it in a very dark sky with naked eye. I have seen the Andromeda, but I haven't tried on Triangulum. It seems a bit pushing it for the kind of skies I see. Next one, please. This was basically up to here was my galaxy season back in March to summer. And then we enter more Milky Way and nebula season. This one was taken in the summer from Italy, is the C11, Caldwell 11, so the bubble nebula. It's basically a bubble created from the stellar wind of a massive hot central star, which you can see if you zoom in there. The picture is taken with filters. A lot of these pictures you'll see from now on are taken with the Optolong L-Extreme filter, which is, so my camera is a color camera, but this filter lets through only some hydrogen and some oxygen lines of electromagnetic radiation. So you can filter out a lot of the surrounding noise and the city noises. So, as I said, this is the bubble nebula and is 145 milliholly of exposure. Next one, please. Right, Crescent Nebula. I took this one from Como Lake, Borto 5, unfortunately. Milan is too near, and you can see it on the horizon, the lights from the city. This one was taken with the cooled camera, the ASI 533 color at -5 degrees. It's a good, tidy 2 hours, 40 minutes of integration. Again, this is a nebula formed by the stellar wind of a Wolf-Rayet star that basically lights up all the surrounding gases. And I think the nebula is the result of a transition of the star about 400,000 years ago. Again, taken from Lake Como in July 2022. Next one, please. Right, Helix Nebula, C63. I took this one back from the Italian Alps this October. It was quite low on the horizon. I haven't managed to take it from London or England yet because it tends to be quite low. The area was a Bortle 4.5, taken with the cooled camera, with the optolong filter. It's only an hour, 12 minutes of integration. It's a relatively bright object and quite big compared to other planetary nebulas. Again, in here one I like because you can see quite well the red of the hydrogen and the blue of the excited oxygen in there. Similar in terms of the other nebulas I've seen. It's in constellation Aquarius and about 650 light years away, I believe, something like that. So relatively near. Next one. Right, everybody at some point gets to the Orsed Nebula. This is my picture for the autumn. It's a 3 hours integration, cooled camera, Skywatcher mount, the larger scope I showed you earlier, and optolong filter to filter out any kind of unwanted light pollution. Next, please. Right, I'm going overboard, so I'll accelerate a bit. Western Whale Nebula, so which is Broome. This was from Lake Como, Borto 5, cooled camera. This is a good, tidy 2 hours and 50 minutes of integration, and you can see the red of the hydrogen and the blue-green of the oxygen. This is part of a supernova explosion that happened something like, I don't know, 20,000 years ago, probably, if I go by memory. And it's just one part of the whole supernova, and I'll show you in the next picture the whole loop. Next, please. Right, this is my latest travel gear. I think people are quite puzzled by that because the telescope is the tiny little part in the center in front of the camera there. I recently acquired, it's a ASCAR FMA 135, is essentially like 135 millimeters long, so like what, 4-5 inches. So very wide, but very well made for astrophotography because it's an apochromatic with field flattener and relatively inexpensive as telescopes go. And I fit it with the Skywatcher and a carbon tripod. So the whole gear you see there and the pictures I'll show you in a minute is only 4 kilos. It can fit in half of my backpack and fly with me anywhere. So I'm still experimenting with this, but it's quite an interesting gear if you want to travel light or take it out from your, from your room into your garden very fast for some astrophotography. Yeah, total weight is probably 4.5, 5, including a computer and cables and the tripod. Next, please. So this is what you can do with that. I took this picture from London, so a lot of light pollution I can see. But this is the whole Cygnus loop. You see the previous pictures in the corner on the right-hand side there, which is Broome. But you can see the whole supernova remnant in one picture because it's so wide field. And we're talking here, what, 3-6 times the size of the moon in terms of field of view from this kind of pictures. Next one. Again, this one actually taken from Central London, Bortle 9. It's the Hart Nebula. 3.5 hours it took me, and some heavy processing after that. But with the telescope, because these are quite wide field targets, it wouldn't fit in my bigger telescope, so I'm using the new, the tiny portable one. And I think next picture is the last one, and you'll notice from what I wrote at the bottom there, this was taken from our observer in London. I took this on a Saturday night meeting, my first visit actually to the observatory, in only 1 hour and 15 minutes from the darker, definitely darker skies of the observatory. And of course is the Andromeda Galaxy that fits very, very well in this kind of open field telescope. But yeah, this one is the first picture I took from London. That covers all of my pictures tonight. I just want to say, if I may, Sean, that we just opened an Instagram account for the association. So if you don't use Instagram, I suggest you do. It's fantastic for astrophotography. There's an immense amount of new pictures being added on Instagram from astrophotographers from all over the world. And we now have an Instagram email, instagram@swhas.org. And if you send your pictures there, I'll publish them on the Instagram account of the association so we can give them some visibility. Feel free to follow and join. It's actually a 3-minute job to join Instagram, and it's quite good. I find it very informative for learning astrophotography in terms of seeing what other people are doing. I think that's it from my point of view.
Okay, thank you very much, Antonio.
Thank you.
Okay, so Antonio was saying, you might have picked it up, we've started an Instagram page, and we've not really done much with it. We've just only put it up in the last few days. So it'll be a place where you can drop your pictures if you want to. So the next one is Martin Weston. Now, Martin isn't able to be with us tonight. So he sent in some pictures and he sent me some notes. I won't read all the notes because it's quite a lengthy thing. This is his setup, and he uses an EQ8 mount and an Altair Astra 250 TT with a Vixen Whitefield APO on the top, as you can see. He uses a QSI 660 CCD camera and an off-axis guider with a Starlight Express Lodestar. He uses a Canon EOS adapted for astronomy to 60A. And some of the other bits there, he uses Pegasus Ultimate Power Box and Pegasus Autofocuser and an Intel PC for control. The software that he uses is listed there on the bottom. It's primarily PixInsight, Deep Sky Stacker, and Photoshop. So he has two setups. He's got a fixed setup, which you've just seen, but he also has a portable setup, which is a slightly more downsized system. Unlike Antonio's, I don't know if you picked up from Antonio's, his portable system, including the tripod, it's a carbon fiber tripod, weighs just over 4 kilograms, the whole setup. The one that he took the Andromeda Galaxy with, that was just 4 kilograms. It's amazing. So he takes that with him traveling. It's only a tiny little scope, but it's great for wide field. This is Martin's portable setup, still quite chunky and to carry around, but it's a Skywatcher EQ6 with a Vixen 103 AX103 APO, Williams Optics Star 71 APO, and 50mm guide scope with Williams Optics as well. So that you can see them all stacked up here. Again, this is the Cygnus wall, which we've seen a couple of shots of. And this particular one, Martin took it on the 12th of May, and I don't know what the exposure times on that, but it's quite a lot using the filters, I would guess, as well. Then the North American Nebula, again, that's located in Cygnus, and again, it's I don't know the filters he's used, but I guess that we're looking at the narrowband filters that are probably sulfur, probably predominant there. I'm not sure. There's no other information with that. Now here's one, the Rosette Nebula, again a very well visited nebula. And this is on Monosaurus on the Milky Way. And when did he take that? And he's not said. So it's an H2 region. So I guess that's what he's used to get the detail there. You can quite clearly see the stars in the center as well, and the shock waves that's been created as moved out. This one is NGC 7008. I'm not really familiar with this one. It's a planetary nebula 2,800 light years away from us in the constellation Cygnus. I mean, Cygnus has got an awful lot of active components in it, hasn't it, if you think about it. It's approximately 1 light year in diameter, according to the notes here. So its popular name is the Fetus Nebula. You can see why. This one is NGC 2359, an emission nebula in Canis Major. And it's approximately 3,670 parsecs away and 30 light years in size. That's quite a big object, but an interesting one because it's got a Wolf-Rayet star WR7 in the middle. This is the Jellyfish Nebula and is a galactic supernova remnant. It's roughly 5,000 light years from Earth, and it doesn't say what the diameter is. It's quite a big nebula, I guess. And it's the remnants of a supernova that occurred somewhere between 3,000 and 30,000 years ago. Horsehead Nebula, another take on that one. Again, it's an iconic image that's very popular. Quite a small object, so you need to know what you're doing to get it captured properly and framed properly like that. And basically, as you know about the Horsehead Nebula, it is actually an area of dust that obscures the light from behind, and that gives it that effect. That was taken from Martin's home at the beginning of January. And another picture here of the Cygnus wall. Again, I don't know what the filters used are here. I wouldn't be hazard a guess, but it brings out the different aspects of it. It looks very foreboding in this image. In fact, I think it looks like a storm more than anything else, really. And finally, the Milky Way galaxy, taken from a dark sky site in Norfolk. There's a lot of stars in that picture. You probably the screen probably doesn't do it justice, or the resolution and the contrast. The image on the laptop is much better, I must say. And Messier 31 again, another well-framed image of that, and you can see lots of detail, the dust lanes and so on in the satellite galaxy. M110, yeah, a good image there from Martin, nicely proportioned. And a picture of the solar eclipse taken from Spain in 2018. Sorry, lunar eclipse. Yeah, so the Earth's shadow casting on the moon causes that red effect. So that's Martin. So we have Steve up next. So Steve, if you could come up and guide us through your images, that'd be very good. Thank you.
Evening all. I've taken all these images from my back garden in North London near Potter's Bar. These images show a variety of astronomical objects, including deep sky, solar, and planetary, and hopefully demonstrates what can be captured in less than favorable conditions. They all require different techniques. I only use one-shot color cameras as they make things slightly easier. The rewards are quicker, and certainly quicker than narrowband imaging. The sensitivity of modern cameras means that the results one can achieve during gaps in clouds are pretty good. The only exception is for solar and lunar imaging, which are captured using a mono camera, which gives me higher sensitivity and resolution. Color is added at a later stage during processing. Please interrupt me if you've got any questions. We're at the end. So this first image is, well, it's the moon. this is actually captured in high definition. It's a montage of 15 separate frames stitched together, and each frame contains about 6,000 individual frames. So there's basically 90,000 photographs in that one photograph. The original image is about half a gigabyte, and it looks much better zoomed in or printed on a large scale. The next picture shows the detail of the above image. So that's a single panel detail showing Crater Tycho. Is this later going to work? Yeah. As well as other major craters disappearing into the lunar sunset. So this was actually taken before Jupiter's opposition, where over 4 consecutive nights, where the seeing was actually very good. The size of Jupiter there is 50 arc seconds, which is quite large. This was taken with my collimated C11. I always think it's very important to collimate the telescope if you've on SCT before every planetary imaging session. So it takes a while to sort of get used to it, but I can now collimate my telescope in 2 minutes. Good polar alignment is also very important. I use something called an ADC, an atmospheric dispersion corrector, which corrects the blue and red fringing you often see on planets, especially when they're low down. To get a decent sized scale, I never use a Barlow because I think it tends to destroy the image. So I use a processing technique in auto stack Hertz called drizzle. I always stack my images at 1.5 drizzle, which increases the scale of the images. But I mean, that image of Jupiter on the left-hand side, I mean, you can't really see it here, is, you know, it's pretty detailed. Next is Saturn, taken at around the same time with good seeing, also with a C11. Because the rotation of Saturn is much slower, I can take longer length exposures, longer captures. All these captures are taken around 200 to 300 frames per second with the camera, which is an ASI 462 camera. With Saturn, you're looking for good cloud bands, good consistent Cassini division in the rings. And this is probably my best image of Saturn so far. Next is Mars. So again, Mars is at opposition at the moment, just past opposition, but the seeing at the moment is terrible. But I captured the one on the left-hand side, which is quite a long time before opposition, and there's quite a lot of detail in there. I took this one last night. It's a bit smudgy, but it's big, and there is actually some detail in there. Actually, what's quite interesting is here and here you can see Olympus Mons, which is the largest volcano in the solar system. It's 400 miles wide and 16 miles high. The dark areas are canals built by Martian ancient civilizations in preparation for the Earth invasion. Either that or they're areas that winds have cleared away red dust, exposing the outcrops of rock, which are primarily basalt. This is a montage of various images of the planets I've taken this year. Moon, Mars, Jupiter, Saturn, and Uranus, and a couple of moons of Jupiter, you can see there. Next, we're to the Martian, the occultation. This is a video I took at 5 o'clock in the morning, showing the moon disappearing in real time, disappearing behind the moon. It was a beautifully clear morning, but very, very cold. And well, was it worth getting out of bed for? Maybe, I don't know. So after taking that, I managed, after stacking, I made that. I found because the moon and Mars apparently move at completely different speeds, and the easiest way to stack that image was actually only to take 1 second worth of video, 300 frames, and stack that. And with that, you know, the definition isn't great, but at least, you know, I've got an image of the moon and Mars in one shot, and they're reasonably sharp. This is my take of Moonset. This is not, I was trying to sort of get the Apollo 8 version of Earthrise just by rotating it by 90 degrees. Also called cheating. So solar imaging, this is what I really like to do. So this is an image comprising of 4 images, 2 of the surface and 2 of the solar flares. The flare is many hundred times the size of planet Earth on a day of good seeing. It's obviously hydrogen alpha, and you can clearly see sunspots, spicules, other solar features and flares, reaching up to 1 million miles across the active sun's surface. All taken from my back garden in North London. And as we're all finding out this month, it's really nice being able to capture a star wearing shorts and cooking a barbecue and drinking a beer at the same time. So this is the eclipse on which was taken on the 25th of October. There we go. This actually got me a top pick nomination on Astrobin, which is quite a good thing to do. The great thing about this image is that it was completely cloudy from where I took these, and there was a 30-second gap in the cloud, which allowed me to take that central image. So I was quite pleased with that. Here we go. This is the Hubble Nebula again. The interesting thing about the Hubble Nebula is that the actual nebula is 4 light years across, which is the distance between us and Alpha Centauri. So it just shows you how big the Hubble Nebula actually is. California Nebula. I've got a lot of detail about that, but you can just Google it. Taken with a wide field telescope. This I titled James Webb, Bring It On. So this was a capture I took about a year ago of Stephan's quintet, which is that, and what's called the Deerlit group, which is this group of galaxies here, with the beautiful NGC 7331 galaxy, which is about 40 million light years away. These other galaxies are around 300 to 400 million light years away, including Stephan's quintet, which is a group of interacting galaxies. This was chosen as one of the first images released by the James Webb Space Telescope, a Hickson group of interacting galaxies. So that was my image there, and that's what James Webb sent back. And mine costs less than NASA's version, but it's not quite as good. But anyway. Finally, my last slide this evening. Yet again, it's M31, M32, located 2.5 million years from Earth. I included this picture as it offers a somewhat different take on this popular object in our night sky. All the stars you normally see in a similar picture have been removed. I've removed the stars so you can visualize what M31 and M32 would look like if you were viewing the galaxy from just outside our Milky Way. And that's my lot. Thank you very much.
Thanks very much for that, Stephen. There's a really interesting collection of images there. And I think one thing that surprised me this evening is the variety and the quality of the images we've seen. Some I've never even thought about it were possible. And hopefully it gives encouragement to some of you to try some of similar things. So With that, thank you to all of those who contributed to make the members' images work tonight. And next, we're going to have Richard, who's going to bring us through on a little bit about what's up in the night sky in the coming months and weeks. Okay, thank you.
Everybody hear me? Great. Okay, a couple of things I'd like to say before we start is the Andromeda spiral. Now, I went to a very interesting talk as part of the Society for the History of Astronomy, where a guy said that it actually has a warped galaxy. And he said every single picture that he's ever seen has always had it inclined. So if you put it straight, you actually can see that the galaxy has a warped center. And that was a complete shock to the astronomical community, and he's eventually got it that he's accepted that that is the case. It is actually a warped galaxy. So it's only because of the orientation that we normally see that gives us that illusion. Okay, so last month I was talking about planets mainly. We were talking about Jupiter and Mars. Couple of things on Mars. Mars is really bright at the moment. It's just past opposition, as Stephen said. One or two things that we need to know. We have a problem with Mars, mainly because it's close to us. That is that the orbital speeds of them are relatively similar. So when it actually, that's why we have this problem with 2 years between each opposition. The other outer planets are moving so slowly that we catch up, we lap them very, very quickly. But with Mars, that's not the case. So that's why you get these 2 year gaps. The other thing is that Mars's speed of rotation is actually very similar to the Earth's. So if you look at Mars one night and you go the next night, you're going to see almost the same thing. So it's not a sort of trick or anything. If you think, well, I keep saying the same bit, you will. And you have to wait about a couple of weeks because of this synchronicity. So that's something to remember about Mars when you're observing it. And also, it's very small. And to back up what Stephen was saying, the seeing has been really bad. And I had to look at it a couple of nights ago. In fact, just to prove it, I've got the eyepiece I used in my pocket. So I haven't emptied one. There we are. There it is. And I will say that all I could see was a smeary sort of blob. So you have to bear with it. And when we get better conditions, we'll see it better. So talked all about planets last month. So I'm going to go talk about something different. Now, this particular year, we have a very good opportunity to see the winter sky with added details. Now, because we're now looking at the Orion arm of our galaxy, we have a lot of bright stars that, in fact, winter, I should say December, January are the time when we get the brightest stars in the sky. The summer, which is obviously has a lot of bright stars, but that is much more muted because we're looking at the Sagittarius arm, that is further away. So we're actually more immediate and close up with the brighter stars. We have an awful lot of bright stars. You can think of them. You've got Procyon, Sirius, you've got Capella, you've got Aldebaran, you've got Betelgeuse, you've got Rigel. You've got the two bright stars in Gemini. This is Gemini over here. There's Gemini. You've got a huge number of really bright stars compared to the other seasons. So this is a good time to go out and just have a look at the sky. And of course, at the moment, we've got Mars. Now, that Mars is very near Aldebaran. And that's interesting because Aldebaran is a reddish coloured star. And so, of course, is Betelgeuse. So what's going to be happening over the next couple of months is that Mars is going to get dimmer because it's getting smaller, because we're now on the far side of the opposition. So as it moves, as the two planets separate and we pull ahead, Mars will appear to get smaller, and that's quite dramatic. So what will happen is that it'll be dimmer. So it'll be interesting to compare the three stars, or the two stars on the planet, and see what the how bright they are. Obviously, at the moment, Mars is much the brightest. So this month I've spoken about observing Mars, but there's one or two things that I'd like to say. One of them is that binoculars are very good for observing. In fact, a lot of astrophotographers, because they don't have to guide, so in that very painstaking way of looking through a little reticule thing to guide their images, they now do binocular astronomy while they're waiting, because you've got time to do that now, which is also echoed by professional astronomers that go out and actually have a look at the sky while they're doing something, because the technology deals with what they're doing. They don't need to be quite so hands-on. And it's a very good idea, because it gives you're doing two things at the same time, which is always handy. But it gives you a much better appreciation of what you're looking at. And that's why professionals do it too. It's not just because they like a pretty sight. They like to gain an insight into what they're really doing. So we're going to do a little, if I can just get that a little bit bigger. Yeah, there we go. What I'm going to do, I'm going to take us on a little star hop that you can do. I'm going to get the constellations up first, I think. Constellation lines. There are they? There's the constellations, and let's get the lines up as well, just so we can see what we're doing. So you can actually do quite a lot of astronomy with using binoculars by actually sky hopping. So I'm going to go back a little bit now, so we go a bit I'll get that bit in quiet. There we go. That's it. So one of the routes that I've used binoculars for is to have a look at several globular clusters, several open clusters in one evening, and that is a very good thing to do. It gives you an idea of what, where they are, and also the differences between them. And by using binoculars, sweeping from one to another, you can do quite a few in one evening, and you also get. If you're doing a messier list and you're filling in ticking each box, this will tick a lot of boxes. If you start off with Perseus, between Perseus and Andromeda, that star there is Gamma Andromedae, which incidentally is a very attractive blue and yellow double star for fairly high power and small scope. About here is located M34, which is a very nice open cluster. It's quite easily split in binoculars, actually, and so that's your first object. Then you can swing over to Taurus, and you've got three clusters between Auriga and Taurus, and they are the three clusters M36, M37, and M38. Now, you can actually sweep from one to the other, and you're not going to get a very detailed impression of them, but you can tell straight away that they're different. M38 is quite dotted with stars. M36 is a bit sort of splashy. It's not a deep cluster, but it's got quite a nice sort of pattern of stars. But M37, which is tucked away a little bit off to the side, is actually a misty sort of patch of stars. So there's three distinct different clusters, and they can be distinguished in binoculars. I know because I've done it, and I've done it relatively recently, so they should be able to do that. So they are located here. They're located between Riga and Taurus, and you can easily find them. I mean, it's not a difficult thing to do. If you find Capella and then sweep downwards, you'll come across them, and they're fairly obvious in binoculars. So there you go. I've got 34, 36, 37, and 38. Then if you go to Gemini, you'll find another one. There's M35, which is located here by the star Iota. Now that is a really attractive cluster in almost any telescope. It's pretty good. It's good in the large telescope. You do need good a reasonably dark sky to see it. It's got a spiral structure and an orangish star in the middle, which kind of distinguishes it. So there you go. You've got a whole set of, you've filled in ticks and boxes on the Messier list. And then we go, what I want to do now is to actually see if I can find Cassiopeia. So that we come down here and go up a little bit, bring it down. We've got Cassiopeia, so I'm going to go up and bring it down again if we can. Yeah, there we are. So Cassiopeia, let's turn off the names, I think. It's a little bit confusing. I didn't know that. Cassiopeia is a W in the sky. It's the chair of the lady the boastful queen that said that her daughter was more beautiful than one of the nymphs, one of Poseidon's nymphs, and got condemned to be swung around the sky in a circle, dips into the water, which from Greece she does, and then thrown up into the sky again. But you can really see that it's a chair. In fact, it's a W, isn't it? Basically. So these stars here that make up the W, if you use these two here, that's alpha and that's beta, and you take a line out to about here, you'll come to a globular cluster, an open cluster called M52, which is another interesting object. Very, very interesting because it's an unusual shape. It's sort of triangular in shape, and that is quite a good view in a small scope. But there's more, because on the line that I've just taken from alpha to beta and onwards, near the star beta, just a little bit in front of it, you'll find a rather unusual star. Now, I came across this by accident. What I was doing, I was actually looking for M52, and I mistakenly went in the wrong direction. I was a little bit off, and I ended up there. So it's a little bit away from the line I should have been taking. And I was instantly struck by a bright reddish star, and next to it was a sort of blue one. It made a double star. And I thought, well, that's pretty good. So I looked it up, and I eventually found out it's let's get this right, W by Cassiopeia, and it's actually a variable star. Sorry, I'll get this right. YZ, WZ, that's right. That is actually a variable star, and it is also an example of a carbon star. Now, carbon stars are basically red stars that have a carbon predominant atmosphere. What that does, it filters the star's light and actually makes it much redder than it would be if it was didn't have the carbon in its atmosphere. So they're actually catalogued separately, but they're interesting. Carbon stars are all around the sky, but they're most of them they are something that even people that say I can't see any colour in the sky, that they say, well, that looks a bit red. They really are distinctive. So I found that by accident. It was only afterwards I found the back history of the star itself. But it was just a chance find. So if you've got a go-to scope, it's worthwhile just occasionally switching it off and just trying to look around, because it's amazing how many things are close by some of the wonders that we see. And you think, well, I didn't know that. For instance, I pointed out M38, which is the one that is one of the stars in down in the group here from Capella Riga into Taurus. M38 has another star cluster next to it. That's NGC 1907, if I'm right. That I found by accident as well. I just missed the point and sort of drifted a little bit, and there it was. And I thought, crikey. So I looked that up. So sometimes they're a really good thing, but sometimes just going from point to point, you miss the bits in the middle. So having said that, I think I'll finish there and try and get out over Christmas. If we have a clear night, just go and have a look at it, because you've got planets, 2 planets there that you can see. You've got a lot of bright stars to look at, and even if you don't have a telescope, it's worth doing. And if you've got a telescope, well, there's lots to look at and interesting stuff to see. Okay, thank you very much.
Thank you, Richard. Thanks. Thanks to Richard for that. A lot of interesting things to see there. And that really takes us to the end of our presentation for tonight. And all that remains is to thank you for attending. And I'm really sorry about, we tried to get the heat on, didn't work. But a very happy Christmas to you all. And hopefully we'll see you all in the new year. So have a good Christmas. Thank you.
Thank you, everyone.